Okay. So next topic is bit stuffing. Okay. In the last class, with respect to bit-oriented protocol, we discussed the size of each field in the frame need not to be the multiples of 8, right? So next method is bits. With respect to that, bit stuffing is followed. Whenever the flag, if it is present in the data, okay. So in that case, how to overcome that problem? Okay, so it can be solved by adding one extra zero, okay, one extra zero whenever five consecutive ones follow a zero in the data, so that the receiver doesn't make the doesn't mistake the pattern 0 1 1 1 1 1 0 for a flag. Now consider, see, this is the flag where the particular bit pattern is followed by header, and here is the actual data, okay, so which is received from the upper layer. Here you can see, as per this method, what you have to do, one extra zero has to be added whenever five consecutive ones. Here you can see 1 1 1 1 1 5 times, 6 7 times bit 1 is repeated here, right? After 5 bits, 5 times 1 bit, 0 has to be included. That has to be added to this. Then that solves the problem of what we discussed in the bit oriented protocol. As you can see, after 5 bits, 5 times 5 consecutive ones, the 0 bit is stuffed here. Okay, after this, the next bits whatever present in the data is followed here. Okay, and here you can see again, in the middle of the data, you can see 5 ones are there, 5 consecutive ones are there. After this, 0 is stuffed. Okay, in this way we can solve the problem which we face it in a byte oriented protocol. Okay, once this frame is prepared at the sender side and sent to the receiver, once the frame is received at the receiver end, he'll identify the stuffed zeros, okay, and he will remove that stuffed zero and retrieve the actual data. Okay, this is how bit stuffing works. You have to remember this. After 5 consecutive ones, 0 should be added. Okay, so that the receiver should not make mistake the pattern this for a flag here. Okay, so that is how bit stuffing works. Fine. Next functionality of this layer is flow control, right? So now, without getting into, before starting this flow control, I just want to quote an example. Like, see, in Bangalore, we know that there is a too much traffic, right? During peak time, though, it is overloaded, right? So here, what if uh, what if we don't have signals in the road? Then what would be the situation of the Bangalore with respect to transport? Obviously there will be huge traffic, right? And also sometimes it may lead to accidents, or sometimes it may lead to deadlock as well, right? So if there is no control, if there is no procedure followed to control the traffic of the transport system, then obviously it leads to several problems, isn't it? So one solution, the process followed to regulate the traffic on the road, is nothing but what the signals are deployed, right? So at certain points, so this will regulate the traffic, isn't it? The same thing happens in the network also. Okay, what if senders start sending the data very frequently over the network, even though receiver is not ready to receive the data, then what happens? the data packets will be bombarded on the receiver, even though if he is not able to receive all the data. Then what happens? Obviously, the data will be lost in the network, or congestion may be created. Congestion is nothing but traffic. Traffic may be created in the network, right? Which leads to loss of data, isn't it? That is not acceptable if you are looking for a good network, isn't it? So in this scenario, you need to have a uh, what mechanism or a process to control this flow of data over the network. Okay, that we call it as a flow control. Okay, so to regulate the flow of packets over the network, we follow flow control. Okay, so once the sender sends the data, then that should be received at the receiver end at the same rate. If it is not followed, then obviously there will be loss of data or loss of packet, right? So we need a particular mechanism to overcome such problems. Okay, and altogether we call this as a flow control. Okay, so what is flow control? It coordinates the amount of data that can be sent before receiving an acknowledgement. So as of now, you just remember this. Okay, I'll explain you in detail. Okay, let's consider this example. This is the sending node and this is the receiving node. As you can see here, we are as we are discussing with the data link layer, so we'll consider only the things that are that will happen in the data link layer. Okay, so at the data link layer, frames are created, right? And these frames are what sent to the receiver node. And at the data link layer, if the receiver node is able to receive the frames that is sent over the network or the link, then this received frame can be delivered to the upper layer, that is network layer. If the receiver node is not ready to receive the data, then what has to be, see, if this receiving node is not ready to receive the data, then at the same time the producer or the sending node keeps on generating the frames, then what happens? As I said, the data will be lost here, right? So in that scenario, you need to have a flow control. Okay, so flow control is what? Once the data received at the receiver end, if the sender receives any feedback from the receiver, okay, then sender can send the next frame. I'll just repeat. Once the sender node sends the frame to the receiver end, okay, so if he receives the particular frames, then he has to, if he sends a feedback to the sending node telling that I have received the particular frame, then sending node can send the next frame. Okay, so this is how the flow control works. So depending on the capacity of the receiver, sender should send the frames to the receiver end. Okay, if he is not able to receive the data, then the sender has to slow down or should stop sending the data. Okay, that is all about flow control. Okay, after flow control, we discussed error control in the previous chapter, right? So as you know, error control is one of the functionality at the data link layer, and it can be implemented by following two methods. Before discussing two methods, you know that error control is done at the data link layer where CRC is followed, cyclic redundancy check is followed, right? So this is the information that is added in the trailer of each frame, right? The trailer field that is present in the frame will be having the CRC bits, right? So the first method followed with respect to error control in the data link layer is that if a particular frame is corrupted when it is transmitted over the transmission link, then obviously the receiver will check the CRC bits and he'll discard it, right? If any error, if it is not if the frame is corrupted, right? If the received frame is not corrupted, then obviously the frame will be received and the packet will be delivered to the upper layer, that is network layer, right? What is the another method? If the frame is corrupted, obviously it will be discarded looking at the CRC bits. If it is not corrupted, an acknowledgement will be sent to the sender telling that I have received your frame. You can continue with sending the next frame. Okay, that is how the second method works under error control. Okay, so that is a small topic. And after that, next, see, error control I have not included in the slides because we have already discussed in the previous chapter. Okay, so next topic here is connectionless and connection oriented. First, we will see this is very important for you to understand because as syllabus progress, I'll be using, this is a connectionless protocol, or this may be connection oriented. When we start discussing TCP and UDP, okay? So it is very important for you to know what actually connectionless protocol and what is connection oriented protocol. Okay, so a connectionless protocol, that means when frames are sent from sender to the receiver. Okay, so it may be sent to the next node that is present in the network. It will not be having any relationship between the frame 1 and the frame 2. That means frame is independent. Okay, so what does it mean? If a sender is sending 5 frames, okay, when it is transmitted over the network, okay, so when it is received at the next node in the network, okay, so there will not be any relationship between the frame 1 and the frame 2. So these frames will be independent. Okay, so that such frames we call it as connectionless protocol. If such what rules are followed, then we call it as connectionless protocol. See, in general, what we think actually connectionless means there is no physical connection exist between the nodes. So that is not the thing here. So that is not the thing you should follow. Here it says that there will not be any relationship between the frames that is passed over the network. Okay, and next is connection oriented. What happens in the connection oriented? Actually, here, since the name says connection oriented, here actually the logical connection has to be established between two nodes here. Okay, the logical connection must be established between two nodes, the nodes which are involved in the network. Okay, so once the logical connection is established, okay, let me take this. Yeah. See here, consider this. There should be some logical connection, okay, between node 1 and node 2. Okay, first you need to have this. After the connection is established, see, we already studied this in the switching network, right? Virtual circuit, right? So first once the logical connection is set up, the frames are all the frames from this node are transmitted to the next node. So this setting up of logical connection is nothing but the setup phase, and transmitting the frames from node 1 to node 2 over this logical connection is transfer phase. Once the transmission is done, we are going to break down this logical connection, that we call it as tear down. So see, this logical connection is established between two nodes. Whatever the frames that are sent from node 1 to node 2 will be related to each other. Okay, so in that scenario, we call this connection as a connection oriented protocol. Whereas in connectionless, there is no relationship between the frames. So say if node 1 and node 2, the frames has to be delivered to this, it may follow many paths. Okay, say in between you may have different nodes. So one particular frame may follow this path, another frame may follow another path. Okay. Okay, so in that case, this frame, whatever frame passed using this way, need is not related to the frame which is sent uh, through this way. Okay, so that's why it is called as connectionless, whereas in connection oriented, the frames will be related to each other. Okay, that is about connectionless protocol and connection oriented protocol. See, you should have a clear picture about this, because in the next semester also, when you are studying computer networks, there also many protocols, we will say it as a connectionless and connection oriented. So in that case, you should not be in a state that assuming that physical connection is the connection, and when there is no physical connection, and you treat it as a connectionless. That should not be the case. Okay, so that is about connection less and the connection oriented protocol. So next topic is data link layer. Data link layer protocols. So that is protocols which are used in this layer. Okay, so this layers which deals with the flow and the error control. So that we are going to study here. I'll repeat, the protocols which is followed in the data link layer to deal with the flow and the error control. So there are four protocols. One is simple, second one is stop and wait, third one is go back and fourth one is selective repeat. I'll repeat. The four protocols followed are simple, second one is stop and wait, third one is go back and fourth one is selective repeat. So out of these four protocols, go back and selective repeat is outdated. That is not we are using nowadays, but the first one, simple and the stop and wait, is still in the implementation. So those two protocols we will be studying here. Okay, the first one is what? Simple protocol. Let's start with the first one. See here, this is the sender side and this is the receiver side. Okay. Huh. As I said, packet which is present at the network layer is passed to the data link layer, right? Where the packet will be converted into frames, and this frames will be sent over the link, right? Once it is received at the receiver end, if it is not corrupted, then the same will be delivered to the network layer, right? Again, packets will be delivered at the network layer. Actually, in this protocol, what happens? As I said, this is one of the protocol used for the flow. Basically, it is used for the flow as well as error control, right? But here in this, as name says, it is a simple protocol. Here, what we assume that the receiver here, the receiver can immediately handle any frame it receives. So whatever frames that are sent from the sender, it will receive all the frames. Okay. So what does it mean? So the receiver will be in a state that whatever the frames that it receives are all the proper one, and the same will be delivered to the network layer. Okay, so that is how the simple protocol works. I'll just repeat. This is simple protocol. Actually, neither flow nor error control is implemented. Actually, whatever frames, the rate at which the frames are generated at the sender will be delivered to the receiver, assuming that it is also receiving at the same rate in which sender generates the frames. Okay, so that's why it is called as simple protocol. So here, Yeah, that is all about the simple protocol. And next thing here, it is represented. Simple protocol is represented using finite state machine. About finite state machine, you will be discussing in the particular subject as automata theory. Okay, so as of now, you just remember the state, whatever the state of the sender and the state of the receiver is represented here. Okay, so consider this is the sending node and this is the receiving node. Okay, so sending node will be in the ready state, okay, as soon as the packet it receives from the network layer. Okay, so once the sending node receives the packet from the network layer, it will be changed into frame and it will descend it over the network or the transmission link. What happens at the receiving end, once the frame is arrived, initially this will be in the ready state. Okay, so once the frame is arrived, it will start processing that and delivers the packet to the network layer. Okay, this is how the simple protocol works. So initially sending node will be in the ready state. Once it receives the packet from the network layer, it will start making a frame and sends it. Okay, at the receiver end, you can see here the ready initially what the receiver node will be in the ready state. Okay, and once it receives the frame, it will start changing the frame to the packet and then it delivers it to the network layer. Okay, that is how it is represented. A simple depiction is given here. The sending node, uh, this is the network layer, this is the data link layer at the sending node. At the receiving node, this is the data link layer, and then the upper layer is network. So here from the network, if the data link layer receives the packet, and that will be changed and delivered to the data link layer. Once it is received, the same will be changed into packet and delivered to the network. Okay, so similar, the next packet, once it is received at the data link layer, it will be transmitted to the receiving node, and data link layer, once it receives, it will change to the packet and it will deliver to the network layer. So this is how the simple protocol works. Assuming that the rate at which the sender generates the frame, in this at the same rate the receiver also receives the frame. Okay, so it both are happening at the same rate. Assuming that as a factor, the simple protocol works. Okay, yeah.